Today we're going to look at the equation wage versus the different factors: education, experience, and hours worked, and how each of those affect wage, and whether or not we can determine the most relevant equation to give a fair representation of an increase in wage per increase in each factor. So what we're going to look at first of all is question A, using a TC value of 2 to work out what coefficient estimates are not significantly different from 0. So to do that, we're going to hypothesis test using a t-test, as we're doing a single coefficient test on each one. So first of all, we're testing beta 1, and we are looking at a TC of 2. So using the rejection region and the t value of 0.9479, we found that t is less than tc, therefore we don't have evidence to reject the null hypothesis, so we can't prove that this one is not significantly different from 0. We repeat with the following betas: beta 2, beta 3, beta 4, beta 5, beta 6, and beta 7, and we find that beta 4 and 7 both have shown to be significantly different from 0 at the 5% level, and the others have not shown that same. So we've found that beta 4 and beta 7 being experience and hours worked are both strongly correlated to an increase in wage per increase of each of those variables. So that is the answer to question A. Number B goes into, and we start looking at restricting equations here. So we've got equation A and we've got equation B. So the unrestricted model of equation A looks like this, and by removing experience times education, beta 6, it gives us equation B, and we are going to use an f-test to test the variable, removing beta 6, or the beta 6 equals 0. So we're going to use an f-test for this. FC is 3, and then the f value calculated through is 1.1186. And the conclusion being we don't have evidence to reject the hypothesis, null hypothesis. And we can also find that same result using a t-test, given we're only testing one variable. So we run through that again, the result being the same, that we don't have evidence to reject the null hypothesis, meaning that we can't reject that experience times education is a relevant indicator. We look at answers, question C, what restrictions of the coefficients of equation A give equation C. Now we're finding this data from here, from this table 6.4. So equation A to equation C, we're removing beta 4 experience, beta 5 experience squared, and beta 6 experience times education. So that gives a restricted model here and an unrestricted model here. The question we're trying to answer by this is experience significantly related to an increase in wage amount? And we can use the f-test to test that. So we're finding as a result in this one here that we don't have evidence to reject it, so we can't prove that these statistics are significant. Removing experience squared, and experience times education has not been determined to be effective is the result. So D, we've got equation B versus D. So we've got the B versus removing beta 2, which is education, and education squared is beta 3. So removing those two factors, the education factor in general, we are wanting to know whether or not is education significantly related to an increase in wage amount. So we go through, run another f-test, and we do find that with a really high f value compared to the f critical, we have significant evidence to reject the null hypothesis, and we do believe that education is very relevant to wage. E, we look at equation A versus E, and we are removing, in this case, beta 3 education squared and beta 6 experience times education. So we want to know, will removing the quadratic equation and experience times education elements help the model become more accurate? So we f-test that again, and we find that we can't prove these factors. So although the f value is quite close to the fc value, it's not over, so we can't reject it. So it's showing us that we don't have sufficient evidence to to say that the quadratic equation and experience times education aren't related. We may well have that evidence at a higher level of significance. So based on the answers above, we've found that education and education squared are very significant to the model. We've found that due to results in B, we found experience times education has little evidence of significance. Therefore, the model equation A is excluded. We look at and see that in C, we found experience elements had no strong relation to the model. Looking at D and E, taking into account neither have a strong presence of education, we can omit these two. While we have no evidence to suggest that experience is not a factor in wage increase, the data in C and E both suggest that while experience isn't significant, it isn't far off. This suggests that experience would be an element worth keeping. And in summary, the two best equations being equation B and C, for they both have strong presence of education and also experience. In order to know which is the best of the two, I suggest we test them as follows. Unrestricted model B versus the unrestricted model of C, and we're removing experience from the equation into the restricted model of C. So we test that and we find that there is a very significant number here in F. So this shows that we do have experience as a factor in wage increase, therefore suggesting equation B is the best model, as it incorporates important elements such as education and experience while omitting the irrelevant variable which we determined to be experience times education. Thanks again.